On the morning of June 30th, 1908, something exploded over the Siberian taiga with the force of roughly 15 megatons of TNT, 1,000 times more powerful than the atomic bomb dropped on Hiroshima. The blast flattened an estimated 80 million trees across 2,000 square kilometers, knocked people off their feet hundreds of kilometers away, and produced a pressure wave that registered on barographs in England. Residents of London reported unusually bright night skies for several days afterward, bright enough to read a newspaper at midnight. Something immense had happened in one of the most remote places on Earth, and for decades, nobody went to look. The explosion occurred near the Podkamenaya Tunguska River in central Siberia, a region so isolated that the nearest significant town was hundreds of kilometers away. Indigenous Evenki people reported seeing a column of blue light as bright as the sun streaking across the sky, followed by a flash and a sound like artillery fire. The shockwave threw people from their chairs and shattered windows in settlements 60 kilometers away. Seismic stations across Eurasia detected the impact. But Russia in 1908 was in the aftermath of revolution and approaching the upheavals that would lead to the First World War. Siberian explosions were not a priority. The first scientific expedition did not reach the site until 1927, nearly 20 years later, led by Leonid Kulik, a mineralogist who expected to find a massive meteorite crater. What he found was far stranger. The destruction was real, an enormous radial pattern of flattened trees stretching to the horizon, all knocked down, pointing away from a central point. But there was no crater, no meteorite fragments, no obvious remnant of whatever had caused the devastation. The trees at the very center were still standing, stripped of branches but upright, a pattern consistent with an airburst, an explosion that occurred above the ground rather than at impact. This absence of physical evidence is what makes Tunguska so enduring as a scientific puzzle. The leading explanation, and the one most widely accepted today, is that a small asteroid or comet fragment, perhaps 60 to 100 meters across, entered the atmosphere at high speed and exploded at an altitude of roughly 5 to 10 kilometers above the surface. The object would have been vaporized by the heat and pressure of entry, leaving no crater and no fragments, only the shock wave. This is called an airburst event, and it has been modeled extensively. A rocky asteroid of about 50 meters could produce the observed effects if it entered at the right angle and speed. But the details remain contested. Some researchers have argued that the object was a comet made mostly of ice, which would explain the complete absence of meteoritic material and the atmospheric disturbances observed in Europe. Others have noted that Lake Cheko, a small lake about 8 kilometers from the epicenter, has an unusually cone-shaped bottom that could be a secondary impact crater. Though this theory remains controversial, and recent sediment studies suggest the lake predates the event. What is not contested is the scale of what happened and how unprepared humanity was to understand it. If the Tunguska object had arrived 4 hours and 47 minutes later, the rotation of the Earth would have placed St. Petersburg directly in its path. A city of nearly 2 million people would have been destroyed by an object that nobody saw coming and that left almost nothing behind. Tunguska was the largest impact event in recorded human history. It was also a warning. In 2013, a much smaller object, roughly 20 meters across, exploded over the Russian city of Chelyabinsk, injuring over 1,500 people, mostly from shattered glass. The Chelyabinsk meteor was not detected before entry. Neither was the Tunguska object. The sky is full of rocks, and we are only beginning to track them. The taiga has largely regrown. The flattened trees have rotted or been cleared. A small nature reserve marks the epicenter, visited by a few hundred tourists each year who come to stand where something extraordinary happened and left almost no trace. Tunguska is a reminder that the universe operates on timescales and energy scales that make human planning look like an afterthought. The question is not whether another Tunguska-class event will occur, it is when and whether anyone will see it coming.